Welcome to Stemiverse podcast episode 29. In this episode, Peter talks with James Zaki. James is a graduate of Mechatronic engineering and computer science with honors and 14 years of industry experience. He started in industrial automation and then transitioned to application development. Outside of development, James worked as engineering team lead and management in small, medium-sized companies. He worked predominantly with startups and small companies and spent considerable time abroad in France, China, and India. James has always been connected to the education technology space. He's skilled in programming for various devices like mobile, Linux, and microcontrollers. He's experienced at turning product ideas into reality and managing mixed developer teams. James can speak fluent French, which he's taught himself, and he's also one of the organizers of Ozberry, perhaps Australia's largest Raspberry Pi and Maker-related meetups. This is Stemiverse, podcast episode 29. Welcome to Stemiverse, the podcast that helps educators become awesome at teaching STEM, be it at home or in the classroom. I'm Peter Dalmaris, and with my co-host Markus Sharpie, our mission is to bring you the experiences of educators, students, and stakeholders who strive every day to make the teaching and learning of science, technology, engineering, mathematics, and art better.
This podcast is brought to you by Tech Explorations, a leading provider of educational resources for makers, STEM students and teachers. For a limited time only, go to texplore.com/Stemiverse and receive Peter's latest ebook, Maker Education Revolution, a book about how making is changing the way that people learn and teach in the 21st century.
Well, we are back with another episode of Stemiverse. This time it's just me because Markus is in Melbourne. I'm here to talk with James Zaki, who I believe, James, we've met once before at a meetup in Sydney. I believe it was the IoT meetup. I'm not sure if you remember that.
Yeah. G'day, Peter.
Yeah.
It might have been the Ozberry meetup.
No, I think it was the IoT one.
Okay.
It definitely wasn't the Ozberry one. I will talk about Ozberry a bit later, but I think it was at near Central Station.
Okay.
You probably have been to that a couple of times. Anyway, that's a memory I have been talking about maybe 3 or 4 years ago.
Yeah.
So, I was looking forward to this interview because I was very impressed. But you did a presentation, I believe, about Raspberry Pi. I can't remember exactly. Whatever it was, it was good.
Oh, thank you. Yeah, I enjoy sort of sharing the tech with everyone where I can.
Yeah, and I've also been following you. Like, I'm a member of the Ozberry meetup group, but you guys do it on a Saturday.
That's right.
Or a Sunday, and not a very family-friendly time.
Right.
And my kids are quite demanding right now, so Saturdays, weekends are dedicated to them. But I do want to come and actually bring the kids as well now that they're a bit older.
I was about to say, we do get a few people who bring their kids.
Yes.
Some interesting projects they're working on there too.
Definitely, that's what I'll do. So, before we start, would you take a minute, or a few minutes actually, it doesn't have to be just one, it could be 10 minutes, and tell us a bit about you and your background, just to give a bit of context to our listeners.
Okay, background. I guess I've always been a tech head, so I've been sort of coding since around the age of 8 or so, and I remember I have fond memories of that, basically picking up a GW Basic book off Dad's bookshelf and then typing it into the QBasic that was running on the PC. And just exploring and sort of, teaching myself that way. So I guess since then it was a sign I'm a bit of a techie. And then that followed through to high school subjects, through to university, where I did mechatronic engineering and computer science at Sydney Uni. And then after that, just the rest is history, I guess. It's been tech ever since.
We'll get to that.
Yeah, exactly. And what else? I've grown up in Sydney, so originally down around Sutherland area, and then after that on the Central Coast up until the end of high school. Then I moved to Sydney for uni. Lived abroad a few times here and there, between Paris for a few years, And then, back to Sydney.
So you mentioned GW Basic. What is that, and what time frame are we talking about?
What time frame? So I was 8. So that's about 80, 88, 89.
Yep.
So that was a printed GW Basic book that had basic commands in it. So I would sort of use the index and basically, because there wasn't really a tutorial that I was following, I would was that then? Yeah, hang on, I'm trying to go back now. But I just remember maybe that was a bit after actually that book. But it was looking at the different commands that were there and having a go at typing them in the computer, seeing what would happen, and then seeing what errors it would tell me it had, and then trying to fix those.
Yeah, that's called bug-driven development in modern speak.
Exactly.
So that GW Basic, just for our listeners, is a basic language. It's one of the first, I suppose, high-level languages that came out with the first PC. So Apple had one, the IBM PC had one. The documentation back then was very basic, wasn't it? It's not like it was interactive with a lot of examples and practical.
Yeah, that's right. Like now you can find a lot of tutorials and getting started, and a lot of those simple onboarding kind of explanations, whereas this was a raw command, and this is the parameters, and this is not even giving you examples of why you would use it.
Yep.
Just literally how to use it.
So totally different style of learning, right? Because and I suppose just like me, when I was learning how to program on my own, you had one textbook or one documentation book. There was no Google, and it was the only resource. And past that, you just had to do something with the information that was in the book. Typically, that meant write a little program and see what happens.
Exactly. Like it's almost like teaching maths by saying, here is what addition is, here is what subtraction is, but not giving you examples or not giving you many examples on how to use them in different scenarios. You just have to play with it until you figure out how that works.
Yeah. So that memory actually makes me realize how versatile kids are. If you think about it, the only thing that we had was a manual and a very, very basic computer with no internet, no adults or teachers or mentors really to provide some instruction. And somehow we still learned. As an educator myself today, like I spent a whole days trying to figure out how to best create educational materials, educational content to give the student the best possible opportunity to learn. And just 30 years ago, that was not a consideration at all. I'm just thinking, are we going too far? Are we disadvantaging learners by trying so hard to create like top-notch or so-called top-notch materials?
No, that's a good point. I've actually thought a lot about this. And I look back to that time compared to today as if, I was okay to bang my head against a wall many times before I got somewhere. But the reward once you did was a lot greater. So I think, part of it comes down to the reward from and the effort. I think back to, if I can pronounce his name correctly, Miala Csikszentmihalyi. He talks about flow theory and around the balance of challenge to reward. And there's sort of a certain balance that gives you a great sense of motivation or to get in the state of flow where you will just keep going from one thing to the next. And it's challenging enough to not be, or to be rewarding, but also then to not be too much of a burden. And that's something I tried to do when I started Cyclone, which was around creating educational content in the form of how I remembered learning myself, which was having that, exactly as you say, just to have that not being too easy. And then I always thought back to also having options though. So the way in classrooms today, I've heard from teachers the term differentiated learning. And in a way it had that in it before I knew what that term was. I just thought back to it. I thought, okay, what if there's a smart person in the class and someone totally new to tech in the class? How do we sort of cater for all of that on a single A4 sheet? And that was sort of the constraints I put. I said, this sheet of content needs to be challenging enough for someone who's quite advanced or picks this up quickly, but also have an easy enough path to get to the end of it and have that sense of completion for their skill level. So it's something I've just thought a lot about as well.
Yeah. Do you think that maybe that path or that inclusiveness in your design is what was missing 30 years ago? Because I'm sure that not everybody was like you, and a lot of people were just given up immediately.
I guess when I think back to high school computer science, there was a subject that we did, and because I had done BASIC before, I was able to code up a little game. But then for those who just didn't have a computer at home or didn't use computers that much, it would have been much more frustrating. But we all had the same assignment. So we were all graded on this thing which we had different motivation levels of. And there may have been a student there that learnt a lot and got very far, but they would have got a lower mark. But in a way, I was, not that I'd cheated, but because I'd done it all before, this class was just doing a little bit more for me. So effort-wise, they weren't marked on effort, right? It was end result. So that could be the difference there.
Yeah, I've got a similar experience. Like one of the few places in my engineering university days where I was actually ahead of the class was in programming assignments. Everything else was like average or worse. But when it came to programming, it was like pretty much ahead of the class. And people would think that I'm smart, which obviously wasn't. It's just that I had probably 15 or 20 years more experience than they had. And it's just I was more in the flow of those assignments. And I did try to actually go a bit past what the requirements for submitting the assignment were. But I think the amount of time that you put in it and the amount of stress that that you had to go through in order to produce the results on your own, I think that is a big part of the learning experience as well. It's not just producing the outcome, whatever it is, an app or a web application or something else on a smartphone, but the journey.
Yeah, the learnings, where someone has started and how far they've gotten, which makes me think of this, the philosopher Alain de Botton. Yes. He had mentioned, I think it was a TED Talk, he's speaking about meritocracy. And he says, well, meritocracy isn't quite true because we're not all starting at the same spot and we don't all have the same attributes. So you can take someone who's started, at a reasonably well-off position and then see how far they go in fortunate circumstances versus someone who's starting with a disadvantage and then progressed maybe a lot more, but still on an absolute level, they're not near where the other person is. And it's not meritocracy.
Exactly. Yeah, that's a good point. And we see that a lot in classrooms, don't we? Like you've got a classroom of 30 kids and they all come from different backgrounds and the kids themselves are different, obviously, as everybody's different, but still they all need to produce the same outcome, the same assignment, whatever it is, the same written exam, and they are marked on that specific outcome only, regardless of how much effort, how much work they had to do to get there.
And how suited they are to that specific test, which I find is nicely summed up in it. Like there's some good comics, simple, one image comics that sum this up, which is a picture of a row of animals, like a bird, an elephant, a giraffe, a goat, a squirrel. And then I think it's a teacher form standing at the front saying, okay, everyone, you're going to be judged on how well you can climb this tree.
Yes.
And they're saying, well, that's kind of like what a test is.
Yep. Yeah, I've seen that. Yeah. That's an awesome example.
Yeah.
You can't ask a fish to climb a tree, right?
Yep, exactly.
Totally unsuitable.
You say, how long can you swim underwater? They'll ace the class without effort.
Yes. These are just good lessons. I think we already have a lot of really good learnings. Let's divert a little bit now to the present. So you tell us a little bit about your past. What are you doing now? What are you working on?
Oof, that's a good question. I've been freelancing for quite a while now on different projects. More recently, I was working on a blockchain project. And basically, I'm looking to continue in that direction. There's a contract that should be starting soon that will be likewise, on blockchain development or smart contract development. Right. So this is basically a brand new domain in terms of, I say brand new. The technology has been around for 10 years, but this specific domain of Ethereum smart contracts is about 2 years old. And the jobs are now becoming more mainstream, or more visible, I guess.
Well, to our listeners, this is not actually planned. Some of you will have, or hopefully all of you, will have listened to Stemiverse episode 25, where we interviewed Kieran Nolan, who is the blockchain guru from Melbourne. So we actually spent a lot of time with Kieran talking about smart contracts and Bitcoin and Ethereum. So this is an amazing coincidence, James.
Good homework.
Yeah. So let's explore this just for a few more minutes to see if we can get any educational lessons out of smart contracts and blockchain and things of that sort based on your experience. So could you tell us first a little bit about your definition of the blockchain?
Well, the blockchain is the underlying technology that one application of is cryptocurrencies. So basically, Bitcoin is what everyone's heard about. Underneath Bitcoin is the blockchain technology, and basically currencies are one application of Bitcoin. The Ethereum blockchain is doing more in terms of smart contracts, but essentially it's under the hood. How that works does get a bit technical. Basically, it's a whole lot of computers on a network that share their version of the truth, and anything that like a transaction that occurs, for it to be true, it needs to be validated, which is a process of mining is involved in that. Once it's validated, then it gets echoed across the network. Then everyone has consensus on what is true in terms of that transfer from, say, my wallet to your wallet of an amount. So I can't then say, no, you didn't pay me, or likewise, you can't say, oh, I didn't get paid, or whichever way. And because it's stored in an immutable record on the blockchain.
So the idea behind the blockchain, then, the way that I understand it, is that once a transaction has been validated and approved, everybody gets a copy of it. So everybody has a complete copy of every single transaction and event that has happened.
Well, every computer that wishes to be a node on the blockchain network, yes.
You don't have to have it, but you can choose to get your computer to be a member of the Bitcoin network or the Ethereum network, for example. And you've got a complete copy of a ledger, basically, of every transaction that has ever happened. If you choose to have your computer as a node to the blockchain network, then you have a complete copy of the whole history from the beginning.
There's new ways of doing it now where you can choose a light sync mode. So you can be a node, but actually only synchronize an early amount of data. You don't have to go too far back. You can just have recent data. But yeah, if you want to be a full node, then you can go and get all the history and store the gigabytes worth of transaction data.
So the new way of having a lightweight sync, is that applicable to Bitcoin or to Ethereum?
Yeah, so that's Ethereum. I'm not too sure if Bitcoin has the same thing, but I know with Ethereum, that's what I'm doing now.
So how relevant, like with Kieran, we spent a lot of time hearing about how he applies the blockchain to teaching and about the smart contracts that his students design and things of that sort. Have you got any similar experience with this technology? If yes, can you tell us about it?
Yeah. I was going to start with actually even just the concept of wallets and addresses and what that means, because I was just explaining to a client this afternoon, or earlier today, sorry, around a wallet, and it's very difficult conceptually to grasp when we're so used to bank accounts. We're so used to the bank holding our account, and if we lose access to the account, we can just call the bank and say, hey, it's me, and get access to our account. But on the blockchain, it's literally a number, a public key, and you have to hold a private key, and that's it. There's no name, there's no metadata with the account. It's simply a number that you have and the private key that can sign transactions from that number.
So what's a key, if you could explain that?
Yeah, so a private key is something you can use to, basically you generate a public-private key pair, and with the private key you can then sign transactions. So if I wish to send you money, I will say, yes, from this address that is me, send money to this address that is you, and I will sign that with my private key so that everyone who sees that knows that it came from my address. So I can't write a transaction that says send money from you to me and sign it myself because it's not from the source, which is you.
Right. So the key is a bit like the signature on a traditional check, right?
Yep,
the
exactly.
bank will then verify that signature against the records and execute the check. In a similar way, the recipient will look at the digital signature, which is really just a series of numbers and letters,
Exactly.
and then verify that it's coming from you.
Yeah, the type of keys we have, that are used in blockchain are much more secure than a little scribble.
Yes.
So, and especially when you think about PIN codes, or that's even worse. But
Right. So you've got so you got the concept of the wallet, which requires, I suppose, a little bit of education to happen. People are not used to the concept because we are used to a trusted party, let's call them trusted party, which is the bank holding on to assets that we own, like money, currency. The concept of the wallet now does not require a trusted party.
Yeah.
Right. Can you give us a couple of examples of how the concept of a wallet or blockchain potentially can be used in education?
Yeah, so to bring it, I guess, to smart contracts can get interesting in terms of, being able to teach coding. But the wallets itself, I guess, it can be just an exercise of using paper wallets. So there's this way of, you can generate a wallet and also then print it out on paper, where you'll print something like a QR code and the string that is your wallet. And then they can send each other money. So you would have to go to the address you want to send it to, get the paper wallet, either scan it with your phone or type it in and say, I want to send money from my wallet to that wallet. And to do that, you'd need, like, if you're on the main network, you need real money, but then there are test networks where you can have fake money. So it's really good that there's already this secondary environment, and there's actually a few test networks out there, which is really good for development. So, and also then to be playing with non-real money.
So as an example, let's say you've got a class of students, it could be across a whole school. That class or that school then could set up a test network and set up their own test economy.
Well, actually, they wouldn't have to set up their own test network. They would just log on to the existing test network and create wallets of their own. Yeah.
So every student could have a wallet that is compatible with a test network.
Yep.
And then it can come up with an internal economy that could involve imaginary products or real products and then transact between them instead of using real money, kind of like Monopoly, a Monopoly game, just to make it a bit more tangible.
Yeah.
But at a larger scale, right?
Exactly. And then that way they're sending money to and from each other via blockchain, which in itself is, I guess, in the same way that you may create an example as to why to use Excel or, type something in Word that they could write by hand. It's just an exercise to use the tool. Going further into smart contracts would then be, a bit more interesting.
So what can you actually learn when we talk about outcomes, educational outcomes? What can you teach through this kind of setup? I've got in my mind things like economics, like entrepreneurship and things like that. Do you think that is a way of introducing these concepts to young students?
It could teach, I guess, distributed networks to some degree, just to say, or to teach consensus, to say, look, if we all agree on something, then that is the truth that is shared amongst us. If someone disbelieves it and they say something else is true, if they say my wallet has 1 million Ether or Bitcoin in it, no one else needs to agree with that. So therefore, no one will be transacting with that node, or I guess it's called a fork when you get different versions of history, where those who wish to go down the fork of that being true can continue down that path, but it's effectively a separate network then, because it's forked from where everyone else is believes to be true. But yeah, in terms of learning outcomes to the curriculum, I'm probably not the best to map it to something that's there, but it has its different levels of complexity and different tools to use to achieve that. So part of it may be just using the tools, the blockchain, or accessing blockchain wallets and whatnot.
Yeah, this is something definitely that I am following after having my chat with Kieran and yourself. So I'll be looking at this. Let's move on to another thing that I want to ask you about, and that is the Ozberry meetup, because it's I think, is this one of the largest or perhaps largest Raspberry Pi meetup in Australia?
I'm not too sure, actually. I guess when Andrew started it was around the Raspberry Pi and also other open source hardware and IoT in general.
I can see you've got over 2,000 makers, members.
Yep, that's right.
Lots of reviews, 82 past meetups, which is quite impressive. When did it start?
It looks like, I had to check the date myself actually, it was 2012.
Yeah.
And Andrew Stone had started that, and I'd started attending pretty much around that time. And it just really resonated with me. I was just, turning up every month, and I would bring my own things to do, but then I found it was just such a good environment that, everyone would be wanting to talk about their projects and what they're working on, what they're looking to do next. It's just this beautiful collaboration of people that were just, around a common interest, I guess. And, I found that I was doing more, socializing and talking about tech than I was actually making my own stuff.
And I know that Philip Mallon is one of your members, who is our guest for Stemiverse episode 10.
Excellent.
And I know that he's been doing some really amazing presentations there over the last couple of months. Unfortunately, I couldn't make it again. Could you describe what happens during a meetup on a Saturday? I think you meet once every month, is it?
That's right, yeah. So we meet once a month in the middle of the month, roughly speaking. We're just about to plan the dates for the rest of the year, actually, due to something with the university, but I can touch on that later. But basically, people will turn up at different times. We set the times, roughly from 12 to when we get access to the space until around 4:45 when we have to hastily pack up for the university to lock their doors. And from when people get in, it's quite casual. People will just find a place. Some of the regulars will just say hi if there's someone new. But after a while, you start to recognize people if they've been before or not. And after maybe about an hour or less than that, we'll do a general round of introductions. And everyone will go around, introduce themselves, what their interest is, what their background is, and also if there's something they specifically would like to achieve, and if they have a question or an announcement. And so everyone can, very quickly, we just hop around the room, and that then sets up the network effect. You'll find someone had a question or was interested by what someone else said, and then people just hop around and ask each other questions and learn from each other.
Right. So I suppose it's a working meetup. You don't just sit back and listen to a couple of presentations.
Absolutely,
so people bring projects and do demonstrations. Yeah,
so most people bring projects. We also have some demo hardware of like Arduinos and Raspberry Pis. And so what else? People can bring their projects. And some people who don't have projects can simply, maybe join other people on the project or use the spare hardware. So we've got things like Arduinos and Raspberry Pis that are available to tinker with. But at a minimum, we encourage people to bring a laptop. And basically, it's a drop-in, drop-out affair from 12 till 5.
Can you give us the theme of a typical meetup? Would you be talking, for example, about new and shiny gadgets that just came out? Or would you be showing people how to do something with those gadgets? Are the beginners or intermediate users? Or?
Yeah, so it's to cater for all levels. We don't have a set agenda for the whole day. We do occasionally have presentations in the middle, so maybe around 2 or so. You've got others, such as Phil, or especially Phil, I should say, who sets up a fair amount of things and is prepared to stand there and demo them, which is amazing. Like that's just, amazing he's able to do that. Yeah. And that way people can come in and have something to see straight away. Because I think for newcomers, it might be a bit awkward sometimes going up to someone and saying, oh, hi, what are you working on? And, I think for everyone there, we really try to remain as friendly and open as possible. Yeah. And, I have to say also that I'm looking closely at the gender balance of this community because it's, predominantly men who are in this community just through from when I've studied through to the workplace, and then even in this community. And I really would like to change that. And I'm approaching different people on getting advice on how to do that. One person, this lady who came along, I spoke with her and she said, yeah, it's a bit uncomfortable. And I said, well, what can we do? And it was from her that I got the idea about the general introductions. Because at first we weren't necessarily doing that. We would just people would mingle naturally. But then I didn't realize as a new person, and perhaps more so as a female, it was quite intimidating. Yep. So I'm always trying to find new ways to say, look, how can we be more inclusive? And recently I reached out to the Women Who Code group, and they shared some resources on that as well. So,
right, yeah.
That's hope to get there eventually, yeah.
And what about the, suppose, background of the people that show up to the meetup in terms of like how many of them would be teachers, for example, versus hobbyists versus professionals in the space of electronics and IoT and especially kids? Like, do you get kids?
I think you've nailed the division there. It's maybe not a third teachers, perhaps a little less, but between say experienced professionals who are working in this field anyway and getting to do a side project, that's maybe some of them. The other, or a third, say, and then the other third will be hobbyists. So people who are maybe brand new or sort of lifelong tinkerers will be there and just trying to discover something new. And and then teachers for the other part. And for kids, we've got basically there is one particular parent who brings his kid, and he's we've got a very ambitious project that he's working on, which is a robot to solve a Rubik's Cube puzzle. And now, for the past, I don't know, almost a year, I've seen this start from a concept to then each month coming in with a little bit more and a little bit more. Last I saw, he had some robot moving the Rubik's Cube. He 3D printed, with the help of someone else, 3D printed an attachment piece for the robot's, I guess, finger to hold the cube. And it's just very impressive to see, this kid and his dad working on this.
How old is the kid? Can you tell us a bit about him and background, perhaps? Whether he's going to a school, particularly interested in particular subjects. I'm very curious.
Yeah. I actually don't know too much about his history. I did meet him and his father at Waverley Library, and it may have been by chance even. Like, he might not have known the meetup was on, and then I think he popped his head in. Or it was the first time he came. But he, since then he's been bringing his kid. I think I would say he's maybe 12 or so, and the younger, he's got a little brother who's maybe 8 or 10, who doesn't do as much as him, but still for his age, he's just doing incredible things.
Well, I made a note to ask you later if you can connect me with them, because I think they're going to make a great interview.
Absolutely, yeah.
Great, okay. Let's switch to teachers again, still with Ozberry, but I'd like to dig into what teachers do when they come to Ozberry and why do they come over?
Yeah, we've got a very interesting teacher who comes along. Her name's Kiki, and she, I guess, had been with Ozberry for a while as well. And she's taken some resources from some of the workshop, one of the earlier workshops that were done, and brought that to her school. And then since then, I guess she's developed the content and come back and is just, I guess, continuing to increase and improve what she brings to the classroom. Mm-hmm. I wish I could, be on the fly on the wall in the class and just see how that goes, just to see what she's bringing from the meetup. But I think there's just a bit of that, the opportunity to ask more technical people questions about the content or about the hardware that you might be experimenting with. And that's probably the core of it. Like, I consider some of the regulars a brains trust that people can come in and ask a technical question and probably get a pretty good answer.
So it's like a support network then, so teachers can use Meetup, as a support network where, of course, they can mix with people that use the technologies that then they take over to the classroom, but also help ask for help, materials, ideas.
Yep. Yeah, so it's possible to just get maybe a quick tip and a bit of help, but also some people are, be it teachers or professionals, looking for engineers to actually work with them in other things, and that's possible as well. Like, people can make announcements and say, look, they're looking for help for a certain project. Obviously stating if it's paid or unpaid is the important part. Yep. But the general, like, if it's like I was approached by an artist at Ozberry who needed some help with her Bluetooth. There was Bluetooth and motors and other things involved in this setup for a really beautiful installation. And so I was able to help her with that for a bit, and then,
Great. What is the let's say the top 3 technologies that teachers use in the classroom to teach STEM topics?
That's an interesting question. I'm going to expand it a bit with define technology, because
yes,
sometimes, like, for like, this is I guess the opinion of Michelle Jensen, and she's a teacher. She was in Australia as a teacher librarian. I think it was head of the New South Wales Teacher Librarian Association, and she would speak of things like, I think, Spyro. Sometimes even the Mindstorm things. There were some technologies that were more so high-tech toys, and they probably wouldn't be as low level as would be sort of beneficial to the students. It sometimes, you may consider sort of grazing the surface a good insight into something, but I think she was of the opinion that it's actually worse by thinking that you're achieving tech when you're really playing with a toy. Yes. It's probably not as effective.
Yes.
So yeah, I guess if you like, again, with the Cyclone content, I used Arduino and Raspberry Pi. They're sort of the two things that everyone's familiar with. And actually, one of the more common questions we get is, what is the difference between Arduino and Raspberry Pi? Which, it's quite a significant difference.
Yeah.
But I would say those two, because if you can learn a bit of Arduino coding, you will be able to use that in other Arduino-compatible products or boards and electronics. The Raspberry Pi is more so the computer, so that's, I guess, a different domain.
Yeah. So if I understand right, you make a distinction between products such as Mindstorms, Spyro, all those really well-refined, let's call them toys. Would that work out of the box, right? And technologies like the Arduino and the Raspberry Pi, which are more low-level, that don't work out of the box. You actually have to do quite a bit of work to get them up and running. And this is a discussion that we had in the past with quite a few other guests. What's your position on all this? Should we be spending time with, especially younger kids that have never had any exposure to bare bones technologies and educational technologies? How do we get them started?
Yeah. And again, I do look back to how I learned, and that's probably not for everyone, just to have a minimal amount of resources and a complex machine to use. There must be some level of gradient, I guess, to get up to speed and make a choice at what level you then want to continue. But to start at only the high level, and then, I mean, unless it's been proven that say something like Spyro that may teach a very, very particular thing, or teach a little bit of a particular thing is effective in teaching that thing, then great. But again, not being a teacher, it's hard to say what is effective in the classroom. Whereas I can just look back to my experience of having the opportunity to look at a complex thing and hit real challenges is much more, I think, beneficial than sort of having a simple problem on a silver platter.
So that I suppose we can use the stress measurement tool if the educational technology is just too easy and it just works once you plug it into power, the student will not get those endorphins of success, like, I made this. Yeah. And the stickiness there would be a lot less than, getting an LED to blink on an Arduino. Absolutely. Right.
I mean, that's the exact example I was going to mention. When I first ran the Cyclone content with Arduino, it was, I often got people starting at the beginning saying, I haven't done any electronics since high school, or I haven't touched these kind of things in a long time. I don't know how to code. And it's like, don't worry. The first thing I'm saying is just relax. It's fine. Don't worry. And then once they do that first LED blink example, literally jumping out of their seats. Yeah, someone was standing up saying, I got it to blink. And there is, as you say, it's the endorphins, it's the joy in that. And that motivation from the past success will carry through to the next challenge. And I guess that's where the flow theory comes in, that the high you get after solving the problem has to then match the next challenge you get.
I see this with my kids. We invest in expensive so-called educational toys. They plug them into the computer. They play around with the thing without actually stressing about it. And then they get bored and they leave it alone. They forget it really quickly. Whereas I give them something else, like a Minecraft is a good example there, because Minecraft starts completely blank, and then everything that exists eventually in a Minecraft world has been made by the child or the player. And then they look at it a few months later and they actually get a good hit of pleasure because they realize that after working on this world for 3 or 4 months, they've got something amazing. And I see the same thing with bare bones technologies like especially the Arduino and a few other things. Like I've seen that with the M-board, with my kids, we'll play around with the M-board and with the microbit as well, which is also bare bones.
Yes.
And just understanding the routine of using block language in the computer to write a little program, then export it, then transfer it onto the microbit via the USB cable, and then the thing reacting and doing exactly what you're supposed to be doing. I can see they are the stickiness, and the more they do it, the more they are absorbed by it. And the other thing that I like about all that, and I don't want this to be a monologue, I'm just talking about my experience, is that it's expandable. So with a microbit, for example, you start with the 8x8 array, and you do all these interesting bitmap graphics there and the animations, and then you just stick a little speaker on it, and you've got a whole new world to explore just with this new little attachment. So I think that's another key, which you don't see in a lot of these other more refined examples.
Yeah, I guess the access to other, I'll call them dimensions almost. Like you've got the coding inside the Arduino that is written there, and obviously then the process to code to it, to set up your computer with the IDE, plug it in, identify the COM ports. So already you're touching upon, the computer, COM ports, and then the code inside the Arduino. But the moment you blink a light, then you're actually doing a little bit of digital electronics. You're saying, okay, this voltage goes high and then it goes low. But by putting a resistor in line with the LED to not blow the LED, you're then learning about current draw or voltage levels, and to say, okay, what is the voltage of this? Then you can look at a battery and you say, well, actually, what's the voltage of a battery? It suddenly applies to the real world. Whereas if you're saying put in, 3 AA batteries inside your thing, you don't know that that's 4.5 volts or...
Yes, absolutely. I think that the closed system just doesn't give you the opportunity to explore all that you could. The open system, the Arduino, whatever it is, the microbit, just exposes you to the guts of the thing, and then you just have to get through to the details.
Yeah, I think you nailed the expression there, the opportunity to explore.
Yes.
And the thing is, you don't have to. So if it's too challenging, you can always just go back to the level you were at before. You don't have to explore, but those paths exist. The opportunity to explore is there.
That's a potential. I think that's I'm just trying to come up with, the 2 or 3 step test for finding a good educational tool. And that would be, I think, what do we say? We said the opportunity to explore has to be there.
The level of challenge.
The challenge, yes. The opportunity to feel good from your work. I think the cost is also a matter there, because you don't want to exclude too many people, too many children. So the cost is an opportunity, is an important aspect as well. So.
I was going to say, you'll find that the more, I guess, raw the technology, the cheaper it will be anyway.
Yes.
There's Arduino, genuine Arduino boards that are $30. But because Arduino is I guess, quite open in how it can be used, you've got Arduino clones.
Yes.
So something that is Arduino compatible, will not be able to have the Arduino logo on it, but you can code it with the Arduino IDE. So you can buy on online AliExpress $5 Arduino clones.
Disposable. Yeah.
Almost, isn't it? Yeah, it becomes quite cheap, but still useful for someone who maybe has a lower price point.
Yeah, absolutely. I find that, and Marcus could actually tell us more about this if he was here, but he was telling me that in many cases, when you want to equip a classroom, a full class of, say, 30 students with Arduinos, then getting the genuine is quite expensive and almost forbidding for many, many schools, whereas you can get a cheap Chinese clone and you can actually stay within your budget.
Exactly.
And I know there's mixed feelings about this whole issue of clones versus originals and
I guess what
genuines.
matters is, as long as the teachers know what they're getting, like if they're buying something that's called an Arduino, then they should pay they will expect it to be an Arduino if they're paying the Arduino's price. But if they're getting a clone, then it should be marked that, yes, this is actually a something else. I don't know, whatever the clone is called.
Fake Arduino.
Something that's cheaper. And, I prefer to support the original one, but I understand then, for lower cost projects or for things like education, then a blend of some clones are useful just to, especially if they're at the point where they're quite young, they may short circuit something, zap the circuit quite readily. And then at that point, you don't want to be zapping $30 every class.
Yep. Yeah, no, that will be pretty bad for budget. Also, you mentioned a couple of times the Cyclone project. I think that's one of your projects from the past.
So a while ago, I got started. I was working in one job, and I had this on the side. I thought I want to do more tech education. I want to help teachers bring tech to the classroom. So then I went part-time with my work, and then I sort of left it to try focus on it. And so I was effectively trying to be full-time on Cyclone, where I was generating educational content. So it's Cyclone, L-E-R-E-N. So it's meant to be like a revolution. And so the idea was to say, let's bring more tech into the classroom. And it didn't quite go as well at the time. I think it was a bit early, and now would have been a better time to launch something like that, because now there's a lot of people doing that. And it was, just to sort of share my learning experience, how I learned, and to try help teachers bring that into the classroom and to not be afraid of it. The content was written in a way, not only to provide what I understand is called differentiated learning, but to be quite atomic in each step. So in one step, you'll just set up the build environment for Arduino, the IDE. In another step, you'll then perhaps use the Arduino to blink lights, but then you'd have a choice. You could say, well, do I want to blink the lights, or do I want to use a button input? And then, there was a bit of a pick a path element to it, so some autonomy of choice in those modules. And basically I was wanting that to be in a format that the teacher could print them off, laminate them, put them in the middle of the classroom with the hardware, and watch the students do their thing. That was the theoretical thing that I had in mind that would be nice if that worked.
So there was basically a set of resources. Can I visualize it as printed materials, or perhaps online with instructions telling or helping students get through certain projects? Yeah,
so it's quite atomic steps. So it was literally one A4 sheet per step, and that could take perhaps maybe 10 to 15 minutes depending on what it was. And the goal was just that the person would be able to know, and this is something that I had the designer sort of work with me on this. They said they were quite interested in the content when they were reading it, because they knew at the end of that page, once they'd done it, they would have achieved something.
Yeah.
So it was that atomic sense of achievement, and then the other part being the autonomy of choice to say, well, what do I want to do next? So the student is owning their learning, but given enough time, the students will be able to get through all the content and actually help each other as well.
Right. Is it still available?
I've given it away for free. I don't know if the website's still up. It probably isn't.
We'll check it later if it is.
I can share it with you later if you'd like to share it.
Sure.
It's perhaps a bit out of date as well.
No worries. It's good, though, to know what has existed. And I find that a lot of these materials actually don't really get old very quickly.
And I guess if anyone does want some more, I'd be more than happy to help them out with some.
Great. Awesome. So just mindful of the time as well.
Yeah.
What's for your future, both in terms of Ozberry and in your involvement with education as well? Have you thought about that?
So just recently I finished, I guess going to the demo of what was called the STEAM Team Expo 2017. Mm-hmm. That was from Quakers Hill Public School. There was a gentleman called Christopher Lambert, and he was really proactive in engaging the schools around him to say, hey, everyone, let's get together and do a bit of a robot building thing. Mm-hmm. And that's what Michelle provided. She'd put together a kit, Michelle Jensen had put together a kit of, very raw robots, very raw components for robots, and having the students program an Arduino plug-in parts, or wiring, I should say, not even plugging in, putting cables between parts. And so this kit had, quite a raw robot build. And all the students developed that and then demoed it. And so that was just the other week that I went back to see the results. And it was amazing just to see all the students from different schools helping each other as well. I'd like to do that again. So or projects like that, I guess. And I think next year he'll hope to do the same. But, on the day of the final demonstration day, it's quite, a lot of mayhem. So probably not the best time to ask. But I'm sure as things settle down next year, he'll perhaps do a bit more of that on EduTech side.
And it's a bit of downtime, just to put things in perspective. So I'm not sure if you mentioned it earlier. Are you working in a company at the moment, or
Yeah,
you're a freelancer, right? Yes.
Yeah, so and then professionally, freelancing and also looking to do my own thing in the IoT, Internet of Things, blockchain space. And it's a lot of just mastering the tools, getting good at this new tech, and finding clients that have a need for this, which is part of the new journey, I guess.
I think blockchain is all the rage for very good reasons. I think you're in a good spot. If you can actually develop a blockchain, I don't know, educational course, I will join in immediately.
Excellent. I'll keep that in mind.
Yep. Oh, well, let's get into rapid fire questions.
Let's go.
Yes. Let's pick one. I've got a whole series here, but let's pick a couple. Well, you're an engineer. What applications can't you live without?
Source tree for my
What's that? Hang on, I haven't heard of that before.
Source tree is a front end for Git, and Git is a repository or a protocol for storing code. I just realized I'm using a lot of terms to unpack here. So the way you store source code is in a repository, and to access that repository, it's nice to have a front end, and you can do more intuitive things from the front end. So I do like Source Tree, which is Atlassian's offering of a front end repository management tool.
All right, so you're not using GitHub, obviously.
I used to use GitHub for Mac, which was a front end, but the underlying repositories are Git as well. So,
I can probably mention that with Git. So Git, blockchain, there's so many terms. But with the nice thing about Git is that it's yet another technology that helps you to never forget work that you've done in the past, right?
And I think it could be used in other domains as well. So even for someone writing a report, having something like Git or even Google Drive does that as well. You could see the historical changes. You can actually look back at how you've written something. And it's like, did you sort of write it from top to bottom, or did you write out a skeleton and flesh it out and over what, what periods of time? So it's quite interesting in that sense to just look back at yourself at how you've written something up.
Yeah, I think for people that are involved in prototyping, like a lot of teachers through our maker-style education, we talk a lot about prototyping. Git would be a tool that would help you keep track of the progression in your project from the very, very beginning to whenever you decide to give up, essentially, because those things never end. It's just when you want to stop using it, so you can see how the whole project evolved.
And also give you the opportunity to sort of take a leap in a random direction. So because you've always got it's almost like playing a game where you've got a last save. Like you can always go back to that point in time in history. And if you want to try go in one direction and another in parallel, you can form a branch of your development. So maybe you branch it and you say, okay, down this path, I want to experiment with this. And then you also can branch off to another path and do something else. And if you like them both, then you can sort of bring them back together and merge them. But that's when you get into sort of coding of features. You do things like branching. But I just find it, sort of fun to do that. So that's probably why that app is on my wouldn't live without, because I like sort of, being organized in my development.
Yeah. And I suppose any developer wouldn't be able to live these days without Git. I can't imagine how we got anything done safely, before it existed, which is not that old. It's actually
saving and storing on floppy drives.
Floppy multiple versions.
That's right, exactly.
Okay. What's your programming language of choice?
C++, I would say.
Cool.
Although I must confess that I haven't used it too much recently. I've mostly used Swift for iOS app development. Before that, it was Objective-C. And for Solidity, it's I guess a pretty straightforward language, and it's quite new, so I don't consider that to be a language of choice. But C++ is what I'm wanting to do next is write code that can run on different hardware and smaller hardware. So that's where C-based languages come in, like C++, and that's what Arduino is really. It's basically a C language. Yeah.
So would you say that for teachers now, speaking to teachers, working with the Arduino as a teaching technology platform, one of the big advantages is that it's using the C programming language.
Yeah, absolutely. Like it may be more challenging than, say, other languages that are more readable. And that is a direction that new programming languages are going. It's towards legibility. Like how intuitive is it to read? So although it's not as, again, it has that challenge that is probably rewarding if you can get through it. And you get enough feedback when you do something wrong anyway that it can get you there. But new languages like Google Go and Swift, I guess, are more intuitive and can have their advantages. So perhaps, again, the opportunity to explore even language selection could be empowering for the students to say, what do you want to learn? You choose your language and then run with that.
Yeah, great. Any parting thoughts for our listeners? So it could be advice, things that you learned yourself the hard way, and things that you advise, say, people that come to Ozberry and ask you about what should I not do or what should I do, any lookouts. And perhaps you want to direct that perhaps teachers or parents who make up the majority, I believe, of our listeners.
I would say don't be afraid of letting your children explore new technology. Sort of let them, even I guess more so the educational content, if it's difficult, let that be, even to the degree of even if the teacher doesn't understand it but knows it should be good, let it be in front of the child because they'll probably pick it up and help you with it. To allow the students to teach teachers would be quite interesting to see. Just because I've understood that there's a bit of perhaps fear or intimidation around a student telling this teacher what to do, but if it's around something that they're proud of and they're owning, then why not be their rubber ducky and say, tell me about it. I'd like to understand, which I'm sure they do. Like I haven't been in a classroom for a while, except, watching maybe the workshops. But I would say, if you can let the student explore something they're interested in and it's roughly in the domain you need to go, then let them at it.
Great. Yeah, it's true. Like, I try to never forget we are all learners, even if we are playing temporarily the role of a teacher. We are really just learners. So,
exactly.
And we can be teachers just for a short amount of time for a specific task that we need to complete. And then we revert back to our normal state, which is to be learners.
Yeah.
Great. Do you like people contacting you?
Yeah. I guess
how can they do that?
It's interesting. I didn't have Twitter until teachers asked me, am I on Twitter? So yes, I've been on Twitter for a little while now. It's James_Zaki is the Twitter handle. So at James_Zaki.
Got it. We'll have that in our show notes. Well, it was a pleasure, James. Thank you very much for making the time. It was a blast. I got so much out of it. We're going to have all the show notes as well. So we're going to break down all the bits and pieces and gems that you provided to make it easy for people to access, include any links we can find. And I hope I'll meet you soon at one of the upcoming Ozberry meetups. I'll bring the kids as well and do something fun together there.
Excellent. Yeah, the next one's on 16th December. So maybe see you there.
Oh, it's coming. It's coming. That's what, in 2 weeks from now?
Yes.
All right. I'll make my case with the wife and the kids. Visit.
You can make your Christmas presents, save money.
Exactly. Oh, that sounds so good. And where is the meetup?
So we run it out of the University of Sydney's ThinkSpace, which is above their SciTech library. So the address is on the event.
Got it.
Yeah.
Sure. Awesome. That's easy to get.
Yeah, exactly.
Well, thank you again, and we'll talk very soon.
Cool. Thanks again, Peter. See you.
That's all for this episode. If you have any questions or suggestions, please send them to our email address, questions@stemiverse.com, and we'd be happy to answer them. Do you want us to interview someone in particular? Let us know. Visit us at stemiverse.com to get the show notes of every episode. And subscribe on iTunes by searching for the name of our podcast, Stemiverse. That is STEMIVERSE. Thanks for listening, and we'll see you next time.